All right, so our topic is networking for massive multiplayer online gamings. I'm Michael Lee.
Alabama brought to you. So for our background information, we had scalability as a large problem for MMOGs. Server needs to handle thousands to millions of concurrent users. So there's different architectural approaches, such as peer-to-peer and client server. Client server is the one that's mostly used, and one of the pros is that it makes it more secure. But on the other hand, everything is exponentially taking more resources, and performance of bottlenecks could occur.
Okay, so the topics that relate to networking include the client-server relationship, peer-to-peer networks, congestion control, TCP and UDP, and latency. For the client-server relationship, most game companies maintain something called a server farm, which is mostly just like multiple servers to maintain the overall game. Players will connect to the central game server, and there's usually multiple models that these MMOs use to connect players. So we got one of them is called the multiple game instances, where like there are multiple copies of the game entirely, and they're kept separate. So the player cannot cross between each game instance without some kind of trigger or mechanism if they on any of these switch servers. Also, there's also called the game regions split, which means that each region is maintained by a single server. So after a player crosses to a different region, their thing will connect to a different server. There's also a called distributed server load, which is like when you split the physics and game computation to different servers, and the player will connect to each one separately, and like they'll reconnect the data back together when we're interacting with the game. And also there could be a split of the AI itself. If there's a large amount of AI in the game in a different server, and the player will also connect to that server to interact with the AI portion of the game.
The other architectural solution is the peer-to-peer network. So it essentially just stores all the data in the client's machines. So the server is built inside the client's machines, and all the peers are interconnected, meaning if one peer changes some instance, then all the other peers will get that information back. So the pros of this is that it's way more scalable than client server. If one fails, then that doesn't mean all the other clients will fail, because in the centralized system, that's one of the cons of it. The cons for peer-to-peer connection is that it has limited bandwidth and it's hard to stop cheating. Also, it's more costly than internet-based dedicated servers. So that's one of the main reasons not many use peer-to-peer network. So some use more like a hybrid approach, or they just take protocols from different parts of the peer-to-peer. And another topic is congestion control. So congestion controls is congestion is pretty much caused by information overload by several users. So one of the solutions to this is having independent copies of the same region of the game, so different instances. So if one person enters a dungeon, then another person can enter that same dungeon, but it's a different instance. And then another is selective dissemination. So essentially, you're just dropping packets not needed. TCP also does this. So, yeah.
All right, the client and servers usually exchange data between each other in the form of TCP and UDP packets. Often, usually a mix of both packets between the client and the server. So usually, most certain actions are prioritized by the game server itself. Certain actions like time sensitive, like combat or movement, that matter to the player to for the smooth gameplay perspective. Would be prioritized. Also, the TCP server will listen for new clients as they log into the games and create a new socket for each one. Also, there's something called the refresh frequency, which is where the server provides data to the clients as often as necessary. There needs to be a fine balance between this, though, because providing too much refresh will result in wasted bandwidth and also could make gameplay lag more noticeable to the player. Or also, sending data infrequently could cause game objects to warp or appear randomly on the screen.
So latency is the last topic. So essentially just the time information takes to travel over a network. So hardware limitation and congestion control causes this issue. So it essentially just leads to an inaccurate depiction of the world and an environment, which can affect how the user interacts with them. And this pretty much concludes our presentation. These are our references.